Hey, happy Friday. I am choosing to wear a hood so that I do not have my hair on YouTube for posterity because it looks like a Friday hair. Let's just go with that. So, we are going over Thursday's stuff. Sorry that it's getting up today. The homework is not going to be due till Monday, so definitely go back over it if you were confused. We have 3 problems today. Jasmine's going to be a creeper in the background every once in a while. And the first one is wordy, so I'm going to read through it once, go back to your blueprint to read it if you need to look at it a few more times. We've got 2 families went to Hidden Figures. The Carlton family had 2 family members who each bought a ticket and $11 of snacks. The Strange family had 3 family members who each bought a ticket and $4 of snacks. The Carltons and the Stranges spent the same total amount of money. How much does a movie ticket cost? The word that tripped a lot of people up here was each. Some people did not notice that each part. That should be a clue that we are in fact talking about some group of things that are happening. So we know we've got a balanced situation because the Carltons and the Stranges ended up spending the same total amount of money. I'm going to over-label just to be super clear about what I'm doing at each step. Then in the Carlton family, we have 2 family members. So I'm going to kind of think about what each person might be buying. The first person bought a ticket and then $11 of snacks. We don't know how much a ticket costs, so I can just say it is T, some amount. And they also spent straight up $11 on snacks. That's one person, but each person spent that much money. So then if we did the same kind of thing for the Stranges, we would see that each person of the 3 would buy a ticket and would spend $4 on snacks too. So we end up with 3 groups, each of which has T for we don't know what a ticket costs, as well as $4. I'm going to start with an equation that you could use to represent this, and then we can talk about solving it. So first, if I want to set up an equation, this is where I can use that grouping that we talked about on Tuesday. I know that I have 2 groups, so I could say that I have 2, and within each group, they spent $11 and they spent T dollars on a ticket. In the Strange family, I have 3 groups, and in each group, they spent $4 and then $2 or T dollars for a ticket. I had some students who also said that that's the same as buying 2 tickets and then spending $22 on snacks, and then the Stranges buying 3 tickets and $12 on snacks. Both of those equations would work. This one shows the grouping a little bit more clearly. So now if I want to solve, I'm going to run through the solutions quickly because you already should feel pretty confident with this. I can take 2t off of both sides to keep things balanced. Now I have none left on this side. All of my t's are on one side. And that means I need to get all of my loose change on this side. So I had $12 total. Let me just get rid of all $12. On this side I had 22. Now I've taken off 12. So now I would have $10. This looks really messy, so let's clean it up a little bit. Carltons are at $10. And the Stranges are at 1 ticket, so we know that 1 ticket has to cost $10. I could plug that back into either of the equations that we created, and we would see that they would end up spending the total amount of money if we did that. That would be substituting it in to check. So that's problem of the day number 1. Voila. Okay. Problem of the day number 2 takes us into slightly different territory. We're adding complexity here because now we have minus terms. What can you do? You can't just put a minus thing onto your scale. I would like to posit that we can think about this as adding balloons, because those are going to make you rise up. I do want to think about it as adding, though, and I don't think that I got this across clearly at all in class, but I am going to talk about it here. Let's rewrite that subtraction as addition. Instead of 2x minus 3, we can add the opposite. We can say that's the same as 2x plus negative 3. So I'm going to use this equation now to write a balance and think about what needs to be on each side. Starting with the things that we know. X, we've got 1 money bag, 2 loose change. We have 2 money bags. What do we do about this? This is negative. We're going to use that balloon. The balloon is going to be negative 3, which is going to just rise that side of the scale up to the weight of what negative 3 would be if it were being lifted. So what can we do to undo negative 3 or minus 3? People immediately started talking about additive inverses. They said, well, if I'm at -3 or I'm at -3, if I want to have 0 balloons, I need to get back to 0. Just add 3. 3 and -3 combined are going to make 0. So that pops this balloon. We're at 0. Since I added 3 on this side, that pulled this side of the scale down. So we need to do the same thing to the other side so that it balances out. Our new scale, to clean it up a little bit, would now look like 2x is equal to x, and we can combine our like terms here, x and 5. More straightforward to solve now. Take x off of both sides so that we are keeping balanced. That means x would have to be 5. And you could plug that back in. 2 times 5 is 10. 10 minus 3 is 7. 5 plus 2 is 7. Check. So that's a way we can start to approach minuses, minus terms. But we can also do minus bags. We can just get weird real fast. There's even more people in here, but they're being so quiet, it's crazy. I'll let them come say hi at the end. So let's say that, oh, let me write that first. Thank you, Elia, for sharing your presence with all of us. We've got minus 4x plus 8 is equal to 3x plus 1. Our minus term at this point is x's. Ooh, so it's just not just minus 4, it's that we have 4 x's, but each of those x's is a balloon. Because each of those is a minus x. This will strain your artistic ability if you're like me. So we are at 4 minus x's, 8 in loose change on this side. And then on this side, straightforward. 3 bags and a weight of 1. Okay. Same idea as when we had that minus 3 in the last problem. How can I pop each of these minus x bags? Well, just because we don't know what the number is doesn't mean we don't know what its opposite would be. If you're at minus x on the number line, go to the opposite side on the other side of 0, and you're going to have x. Just like minus 3 and 3, minus 2 and 2, minus x and x. So I'm going to put an x for each one of these balloons. 1x, 2, 3, 4. Now I have 4 x's, 4 minus x's. Each of those will cancel out to 0. Leaving me with no x balloons or bags at all. But since I added 4 on this side, I need to add 4 on this side to keep things balanced. So we're going to add 4 x bags to this side. Not quite done, because we have our loose change on both sides. I can take 1 off of this side, take 1 off of this side to keep it balanced. Now we would have 7. Now we have 1, 2, 3, 4, 5, 6, 7 bags, 7 loose change. Each x must be 1. Let's try it. Negative 4 times 7 plus 8 would be negative 28 plus 8. That would be negative 20. 3 times... I'm sorry. 4 times 7, my bad. We all make mistakes, right? So we said that we're going to go with x has to equal 1. Okay, so I'm going to plug 1 in here. Negative 4 times 1 plus 8. That would be negative 4 plus 8, which would be 4. 3 times 1 plus 1 would be 3 plus 1, also would be 4. Those are, in fact, equal, which checks out. So x equals 1 works for this. Okay? So the things to be thinking about as you're working through these problems that have minus terms, how can you think about turning them back into addition? How can you use balloons to represent those? And then how can you get back to 0? How can you pop those balloons? And the additive inverse, or the opposite number, will always be helpful, whether you know that number or whether it's an x term, a variable, and you don't know what it is. All right. Ladies, do you want to come say hi to the world?
Yes! Hi,
So it's Friday afternoon, and these Super cool people come and stay at school. But this is the Carlton who was featured in the video.
Yeah.
She's making a mural on my wall
I
right
got
now.
Capri Sun.
And they've got Capri Sun. So, have a great weekend. Let me know if you have any questions. You got a lot to prepare for finals.
She's very intelligent.
Bye.
Bye.